Right, these questions you don't have to think much, just follow instruction, and well, the answer for part C, solution for part C, will come naturally later. And let's do part A. Z over W plus I, need to multiply the conjugate, and you expand this properly, so 2, you get CT3, and this is I. You group the imaginary part. Of course, we always like you to put in this form. So 3 minus 1 divided by 2. Voila, that's it. And this is in the exact Cartesian form. Exact because we didn't use any calculator at all. And then next part, we'll do B here, right? And then express Z and W in polar form. Remember, the polar form is the r-cis theta thing, okay? And Z is this one. And so if we sketch this on Argand diagram, it's actually right here. So 3 is right here in the first quadrant. So we know the argument must be positive. Must be in quadrant 1. Is acute, and so we can calculate its modulus. The modulus clearly is 2, and the argument of Z is inverse of tangent of y over x. 1, sorry. so this is x and this is y. So CT3 over 1, and this should be pi over 3. Just you can check with calculator. So you can check calculator pi, and then it's CT3 over 1. Okay, so 60 degrees. So pi over 3. So back to here. So therefore, we know that Z is 2 cis pi over 3, right? And then now for W is 1 plus I, and again, if we sketch this, somewhere here, 1 plus I, and this is it. And if you think about it, this angle is actually pi over 4, right? Because this point is 1, 1, and we can show that. The first we can get the modulus is square root of 2, and its argument of W is inverse of tangent y over x. So y is 1, x is 1, and then we have established that this complex number lies in first quadrant, so pi over 4. So therefore W is square root of 2 cis pi over 4. So hence, otherwise express Z over W in polar form. Pretty straightforward. Z divided by W is therefore a 2 cis pi over 3. This is over square root of 2 cis pi over 4. If you recall, that's one property of cis is that cis theta divided by cis phi is cis theta minus phi, right? So we're going to use this property, and this is this is going to be square root of 2 cis pi over 3 minus pi over 4, and this is square root of 2 cis pi over 12. Right? Alright, so part C is that we want to use the result here, and this result to deduce the exact value of sine pi over 12. So I go to the next page. Right, let me call the pen. let me write this again so we know. Copy in case we have forgotten this. This is 3 plus minus 1 over 2I, and part B just now we shown that Z over W is in fact 2 cheese pi over 12, but we can express this as follows: cos pi over 12 plus I sine pi over 12, and let's expand this. This is root 2 cosine pi over 12. Not really interested in this. We're interested in this. This is 2 sine pi over 12. If you compare this one and this one, right, so here's your I. That means that and this is actually the same. This is both Z over W. So it means that this real part must be similar to this. In fact, they're equal. So therefore, by comparing this sine pi over 12 is this minus 1 over 2, or in other words, the exact value of sine pi over 12 is therefore square root of 3 minus 1 over 2 square root of 2. Isn't it just so cool?